and that value was 3.56 Newton per mm square. Then permissible bursting stress, permissible bursting stress, it is FV permissible, which is 1.8 as per IS 1343 for prestressed concrete. Okay, so permissible is 1.8, and now here it is what, 3.56. So therefore shear reinforcement is required. What is the meaning of this? Now the shear reinforcement is required. Okay, now we need to provide the shear reinforcement. Okay, so I will draw this diagram once again. So now here, this is our x-axis, this is y, now the parabolic curve, this is the parabolic curve. Now the dimensions are, we have already drawn this diagram. So up to the center, and now from this. So this is our highest point, 3.56. Just draw this diagram. This is 126. This distance is 126. Okay. Refer the previous parabolic diagrams which we have drawn. Those distances I am considering over here. 126. This is also 126. Okay, 0.21d, 142d, and then this is 348. Okay, and what is the value? This value is 3.56 Newton per mm square. 3.46 Newton per mm square. हे कुठून आलं 126 आणि हे व्हॅल्यूज कुठून आल्या? It is 0.21d. Okay, you know the depth. Okay, so it is 600. So 0.21 into 600, if you do, it is 126. This total depth, this total is nothing but depth. This total, okay, up to this point, and this total is nothing but it is 600 mm, which is the depth. So now 3.56 is the value actually we got, but up to which value it is acceptable? So it is acceptable up to the value of, we can say, up to the value of 1.8. Okay, so suppose now here somewhere we get the value of 1.8. So I will draw one line over here. Okay, and now this value is 1.8. Here the value is 1.8 Newton per mm square. Okay, so up to this value there is no shear reinforcement is required. Okay, but in this region, okay, 1.8 to 3.56, your shear reinforcement is required. Okay, so for how much length the reinforcement is required, that we need to calculate. So what is the length? So that length is this much length. म्हणजे आता हा टोटल पॅराबोला आहे. ओके, या पॅराबोलाची हाईट किती आहे? 3.56 आहे. तर त्यातलं तुम्हाला अलाउड किती पर्यंत आहे शियर रिइन्फोर्समेंट? की 1.8 च्या आतमध्ये जर स्ट्रेस असेल, कमी असेल, तर शियर रिइन्फोर्समेंट इज नॉट रिक्वायर्ड. ओके, मग म्हणून मी 1.8 ला एक लाईन ड्रॉ केली. ओके, Now, in which area the shear reinforcement is required? Shear reinforcement is required in this area. हा जो parabola दिसतो ना तुम्हाला, in this area the shear reinforcement is required. Okay, so if I draw it separately, the area, if I show you, then here in this area, this reinforcement is required. This is the parabola. Okay, this ordinate is 3.56 Newton per mm square, and here is the ordinate 1.8. So in this area, your shear reinforcement is required. For that, we need to calculate the base. We don't know the value of this base. Once we know the base, we can use the formula of area, okay, to calculate the stress. So let us assume that this length is x1 up to this center point, and the remaining length is x2. This length is x1 and the remaining length is x2. Okay. So the next thing is that I will mention here also. So this is your x1 and this is your x2. Now we want to find out the values of x1 and x2, and we will use the law of parabola. Okay, here we will use the law of parabola, and that law says, remember this, okay, as it is. The difference between this height, okay, so the difference between this height, what is the difference between this height? It is 3.56 minus 1.8. The difference divided by the highest height, total height, 3.56, okay, must be equal to this difference, okay, divided by this 3.56. So this much height divided by total height must be equal to x1 square, x1 square divided by, what is the base? x1 इथं आहे, खाली base किती इथं 126, divided by 126 square. Okay, it is divided by 126 square, which is equal to x2 square. This is formula, divided by, what is the distance इथून ते इथपर्यंत x square. This is xu. So xu is from this point to this point for the higher parabola. It is 348 square. So it is 348 square. So now if you solve this, you will get the value of x1 and you will get the value of x2. Let me know both the values, do the calculation. I don't have calculator with me and I don't have the values right now, so please do the calculation and let me know the answer fast. We need to calculate the total tension force we want to calculate, for which we can provide the shear reinforcement. So force माहित पाहिजे ना, किती force ला तुम्हाला द्यायची shear reinforcement. We know the stress, we know the area. So this is our attempt from the area and given ordinates and stress, we will be able to calculate the force. So to calculate that, we require the base of this parabola, smaller parabola, and to calculate the base, we are doing this. So after solving, we get 88.6 mm, this value, which we will round up to 90 mm x1. Okay, nearly we will take the value. It is 244.7 mm. So we will round up this value to 250 mm. Okay, so x1 plus x2. So base, that is x1 plus x2, which is equal to 90 plus 250, so it is 350 minus 10, 340 mm. So this total base we have calculated, it is how much it is? This total is 340 mm. That is what we got the value, 340 mm. Okay. Now once again, if I draw the diagram, then here you can see the parabola. is the parabola. This is 3.56. Here it is 1.8. Okay, and this total is 340 mm. Okay, and what is the difference between these two? At this point, this is 1.8 Newton per mm square. This is also in Newton per mm square. And what is the difference between these two heights? This difference, it is 1.76 Newton per mm square. Okay, 1.8 plus 1.8, it is 3.6 now. And then here 3.56, 0.4 you can minus. So 1.76. Okay. So from this now we will calculate the tensile force. Tensile force is equal to area above the parabola. Okay. So what is the force now? Now we will do the reverse procedure. It is 2 by 3 into base into height. Okay. This is the area of parabola. Okay. But this will be per meter width. So this tensile force will be per meter width. Okay. So this tensile force will be per meter width. So if you want total, so you need to multiply it by 200, whatever may be the width. So now the total tensile force. So the total tensile force, if you calculate this, it works out to be 79790 Newton. Now this is the total work tensile force. Then allowable tensile stress. This is as per the IS code. Whenever now I am saying as per the IS code here in pre-stress, it is as per the IS pre-stress IS code. Okay. So allowable tensile stress is equal to 140 Newton per mm square. This is standard value. Okay. So now we will calculate the steel required. So again the simple formula, you know the stress, you know the force. Okay. Force divided by stress is area, or force is equal to stress into area. So force divided by stress equal to, you will get the area. Okay. So area of steel AST is equal to, what is my force? Force is 79790 divided by stress is 140. So now after solving this, we will get this as 570 Newton per mm square. Okay. So this is the area of steel required. So this is the area of steel required. So here we will provide the 4 stirrups. Okay, we will provide the 4 stirrups. Okay, two-legged 4 stirrups, so that we can match up with the area. So if you provide two-legged stirrups, what is the area if you take the diameter of the stirrups as 8 mm? Okay, then or 10 mm. If you provide the stirrups of area 10 mm, then what is the total area? It is 100.53. So we will nearly provide the 4 stirrups. Okay. So now I will directly write over here provide. Now you know that once you got the area of steel, how to provide the reinforcement, it is known to you. So I will provide here 8 bars of 10 mm bar diameter, and 4 stirrups of two legs. Okay. So now the next, this is all about the bursting force on horizontal plane. Okay. Now we will calculate the bursting force on vertical plane. Okay. So bursting force on vertical plane. Again, for the vertical plane, one parabolic diagram is there. So we will draw it. This is x and y axis. This is the parabolic diagram. Okay. I will draw. Okay. So this is the parabola. Here is your maximum ordinate. This is called as FH max. Okay. Here the ordinate is at below this point. The ordinate is 0.48d. Here at this point at the start of parabola it is 0.24d, and this is at the last point it is d. So accordingly we will write the distances. So this is the one distance, this is second one, and in between is the third distance. So how much it is? 0.24d is 144. This is 144. Okay. So now how much is this? This is also 144 mm, and this remaining will be 312. And the total depth you already know. This total is how much? This is 600. How to calculate this? Now if you multiply this 600 by 0.24, okay, if you multiply this 600 by 0.24, then it will, you will get the answer 144. This d is nothing but the effective depth. Okay. So again from 0.24d, 0.48d, again difference is 0.24d, again same distance will be here. So if you got these two distances, that is 288. From 600, if you minus this 288, you will get this value 312. Okay, so all it depends upon the value of d. That. Okay. So now we will calculate the bursting. So the bursting force on vertical plane, again formula is Pb is equal to, it is 0.3p here in the bracket, 1 minus b dash upon b. Therefore Pb is equal to, it is 0.3 into 1500 into 10 raised to 3, it is the pressure force, 1 minus b dash by b, it is 0.8. These are the standard ratios which we take. So Pb is equal to, calculate. Okay, so the answer is 90 kilonewton. Okay, so this is your bursting force on vertical plane. Okay, so now the bursting force per height per height of anchor plate. So now per height we want. So this 90 kilonewton, it is divided by height. What is height? It is 300. So if you calculate this, 3 3s are 9. Okay, so it is 300 Newton per mm. is 300 Newton per mm. Area area of bursting stress diagram is equal to, it is parabolic diagram, so it is 2/3 base into height, which is equal to 2/3 into base is what, 312 plus 144. So what is the base? The base is from this point to this length is 144 plus 312. Okay, so 312 plus 144, it is 356. 346, 456. Lecture मध्ये sir. Okay. So it is 144 plus 312, it is 456. Okay. So 456, so base is 456 into height is FH max. Okay. So here you can write equating equating the area equating area to bursting force diagram per height of anchor plate. So it is, what is the area? It is 2/3 into 456 into FV max must be equated to 300. So if you solve this, what is the value of FV max? Calculate it. 0.98. Okay. The answer is 0.98 Newton per mm square. Okay. But what is the permissible bursting stress? FV permissible, it is 1.8 Newton per mm. Okay. So here your FV max, here there is no need to provide the reinforcement. Your FV max is less than FV permissible. So hence it is safe. In previous case, your FH max was greater than FV max. So that is why we have provided the reinforcement. So that is why we have provided the reinforcement. Okay. So this is the only one type of problem which can be asked in the examination for the from this unit. Okay, to design the anchor plate. So this type of problem we have covered now. Now you write down I hope now you have written all the procedure in detail. Okay, so here, sorry, it was mute. I will repeat once again. Here you can see FV max is 0.98 and FV permissible is 1.8 Newton per mm square. So whatever it is generated vertical bursting force, it is less than the permissible stress. So it is okay, safe. But when we were calculating the horizontal bursting force, that value was 3.56 here, and which was greater than 1.8. That is why we need to provide the reinforcement, okay, shear reinforcement. But here it is not needed, not required. Why not needed, not required? Because your maximum stress is less than your permissible stress. Okay. So this is one type of problem which can be asked in the examination for the design of the end block. Okay. The rest of the things are theory, but this mainly the numerical is most important thing. So you go through the numerical once again. At the start, it may look like it is difficult. Okay, when you look this problem and you see the steps to design it, it may look you difficult, but it is not difficult. So now you are having all the steps. Okay, after this lecture, you see all the steps, try to understand the steps, and if still any problem is there to you, you can tell me. I will repeat that part. Okay. So with this, our second section is over now. Okay. So up till now, what units we have covered? We are having total 9 units. Out of 9 units, 7 units are covered. Total section second is covered, and from section number one, first and second unit is covered. Okay. So now the retaining wall and water tank. So it is also very easy. For the retaining wall, in the examination, they will ask you about the cantilever retaining wall. Numerical on cantilever retaining wall. And in the case of water tank, in the examination, the question is asked based on the circular water tank with flexible base. Okay, so only two numericals are there. After covering these two numericals, our syllabus will be over. So in next 2 to 3 lectures, it will be over. Okay, so today, without wasting any time, I think we should move further and we should start this next unit, that is for the retaining wall. Okay, and in the retaining wall, cantilever retaining wall is the important thing. Okay, the numerical will be asked on the cantilever retaining wall. Okay. So the first, retaining wall. So what is the meaning of retaining wall? So any wall which retains the pressure of the soil. Okay, the wall which is constructed or structure which is constructed to sustain the retaining pressure, it's called as the retaining structure. Okay, and if the wall is constructed to resist the pressure of from the soil, then that wall is called as the retaining wall. Okay, so I will give you the heading retaining wall. Okay, retaining wall. So we will see in detail about cantilever retaining wall, and we will see the numerical in detail for the cantilever retaining wall. Okay, so retaining wall. So first of all, we will draw one diagram for the retaining wall. I will show you the different parts to you in that diagram. Okay, so draw this diagram. So I am drawing the diagram of in general diagram of the retaining wall, and I will show you the different parts of it. So this is the cross section of the retaining wall. If I draw its length, then this may be like this. It is going below, behind it, sorry, not below. It will be like this. Okay. Okay. So this will be like this retaining wall, and here it is the backfill level. I will draw the level. This is your ground level. Okay. So here it is the backfill. What area you are seeing here, the behind this area. See, the wall might be like this. It is going. It will be like this. Okay. So now you will get the idea. It is going like this behind. So please draw the diagram. Okay. So this is your retaining wall. This is the diagram of retaining wall. So this part it is called as stem. Okay. So we will give name to the every part. This is called as stem. Okay. Similarly, I can draw this. इकडनं तुम्हाला दाखवायचं राहिलं ना, maybe like this. Okay. This line go behind. So this is the stem. Then the next part, this you can call it as a toe slab. Okay, this is your toe end. Here it is your toe slab. This is called as toe slab. At this end, this is called as heel slab. This is called as heel slab. This is basically this end. It is called as toe, and this end it is called as heel. Okay. This total is the height of capital H is the height of retaining wall. Okay, capital H is the height of retaining wall. And the height of retaining wall below the ground level it is denoted by letter YM, and above the ground level it is by H2. So if I name this, see, this is the ground level. Okay. So whatever may be the height of wall, the height of wall it is denoted by the letter capital H. Okay. So draw this diagram. Also, this part, this is called as top width of stem. This is the bottom width of stem. This is the depth of toe slab, depth of heel slab. Okay, this is where the soil is getting retained on this portion. Okay, so this is called as the retaining wall. Okay, I will write here layout of retaining wall. Layout of retaining. So it is very easy chapter. ऑलरेडी तुम्हाला झालेले ऍक्टिव्ह वर्क प्रेशर, passive work pressure, you know all these things. Okay, so we will take into the consideration cantilever retaining wall. Okay, so first of all, you copy down it with me some important points regarding the cantilever retaining wall. Cantilever retaining walls. Okay, so the first point is this is commonly provided retaining wall. This is commonly provided retaining wall which is which is in the shape of which is in the shape of an inverted T section, which is in the shape of an so we were writing the points in the retaining wall. So first point is over. This is commonly provided retaining wall which is in the shape of inverted T section. Okay. So the second point is its three components are its three components are uh, stem, stem, hill slab, hill slab, and and toe slab. All the components, all the components are are act as cantilever. Okay. So all these components, the stem, hill slab, and toe slab, are act as a cantilever. That is why it is cantilever retaining wall. So the next point is the wall is stable. The wall is stable under the action of its own weight. The wall is stable under the action of its own weight, and and weight of soil and weight of soil resting on hill slab Means what? This wall is stable. कशामुळे stable आहे? So due to its own weight. This is the first point. Due to its own weight, it is stable, and plus it is stable due to the weight of the retained soil. The soil which is retained on the slab. Okay, hill slab. So due to these two weights, this type of wall is stable. Okay. Next point. These types of walls, these types of walls are suitable to retain soil, to retain soil for heights for heights not exceeding. So this is the MCQ question. Not exceeding 6 meter. So these types of walls are suitable to retain the soil for heights not exceeding 6 meter. Remember this. Generally 5.5 meter to 6 meter is the range, but above 6 meter these types of walls are not used. Okay. For cantilever walls I am talking about. In some cases, in some cases, either the toe slab, either the toe slab or hill slab is not provided. Okay, due to which, due to which wall becomes L-shaped. In some cases, the either toe slab or either hill slab may not be provided, but generally it is provided. But in some cases, it may not be provided. Okay, so these are the some highlighting points of the cantilever retaining wall. Okay, so we have already drawn the diagram. Still, we will draw it once again. The cross section of the cantilever retaining wall. Very simple diagram is there. So draw it with me. This is the stem part. This is the width of stem at top. This behind slab is the hill slab. Okay. This is the retaining wall. Here we can show the ground level. Okay, so this part is called as stem. I have already told you. This is your hill slab. And here it is toe slab. Here it is toe slab. This is T-shaped wall. And sometimes the toe slab or heel slab is not provided, then the shape of the wall, I will draw the diagram once again so that you will understand. So when one of those is not provided, then we are drawing this wall. Again, this is stem. If you give the names to this is stem and this is heel slab. There is no toe slab. So this is called as L-shaped wall. This is called as L-shaped wall. Okay. So these are the cantilever wall. Okay, this is the type of cantilever wall. So now, in the same way, the counterfeit retaining walls are also there. Okay, I will tell you the theory of this because the theory of this can be asked in the examination. So I have told you the points regarding cantilever wall. Now I will tell you the points regarding counterfeit retaining wall. So we will see all the points one by one. So the first point is counterfeit walls are counterfeit walls are cantilever walls cantilever walls strengthen 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 with counterforts strengthen with counterforts from monolithic with just 1 minute. So we will move further. So the counterfeit retaining wall are the only retaining walls, but after some interval, some counterforts are added into the simple retaining wall. Okay. So you can see many of the pictures of counterfeit retaining wall on the Google. You will get the idea how it is look like. Strengthen with counterforts monolithic with with the back of the wall slab and base slab. Okay. So now the next thing is next point. The counterfort act as a counterfort act as tension stiffeners and connect the wall slab and the base slab. To reduce bending and shearing stresses. Bending and shearing stresses. Okay. So these counterforts which are provided are act as the stiffeners and they will provide a resistance for the bending moment and shear stresses. Okay. The counterfort used for high walls with heights heights greater than 8 to 12 meters. So it is used for the height greater than 8 to 12 meters. Next thing is the counterfort. The counterfort are provided are provided at interval of about 3 meters. The vertical slab the vertical slab hill slab act as vertical slab and hill slab act as continuous slab. We have already studied the design of continuous slab in DCS 1. Continuous slab Y Y toe slab act as a cantilever act as a cantilever. Okay. So these are some of the important points regarding counterfeit retaining wall. Okay. Now we will take one numerical of the cantilever retaining wall so that everything will get covered. Okay. A cantilever retaining wall cantilever retaining wall is designed to retain earth pressure for 5 meter tall stem. Full stop. The wall retains soil level. The wall retains soil level with its top. Full stop. The soil weights the soil weighs 18,000 Newton per meter cube. So weight of soil is given, density is given, and has an angle of repose and has angle of repose 30 degrees. Okay, so angle of repose is also given. So you know that what is the angle of repose? Phi. Safe bearing capacity of soil is 200 kilonewton per meter square. The safe bearing capacity of soil is 200 kilonewton per meter square. Use use M20 and 3415. This is the given problem. We will read the problem once again. A cantilever retaining wall is designed to retain earth pressure for 5-meter tall stem. The wall retains soil level with its top. The soil weighs 18,000 Newton per meter cube and has angle of repose 30 degree. The safe bearing capacity of soil is 200 kN per meter square. Use M20 and Fe 415 stick. Okay, so this is the given data. Now we are going to solve the problem. So the first thing, first we will consider the wall portion. So in the wall portion, width of stem at top. Okay, width of stem at top, which is equal to 200 mm. This is the minimum width we should consider. Minimum width should be considered. If it is not given in the problem, this is the minimum width you should consider. Okay, this is the minimum width you should consider. So the width of stem at top. So stem portion, the topmost portion of stem width is 200 mm. Okay. So now we need to calculate the thickness of, if I draw here the stem, okay, stem is look like this. This is the stem. Okay. ఇక్కడ आणि ఇక్కడ कंटिन्यू असणार आहे. So this is the top portion. This portion is top portion. And how much is this width we have considered? 0.2 meter, that is 200 mm. Now this we need to calculate. Okay. This we need to calculate, and this, that is the width at bottom. Okay. So width of stem at bottom we need to calculate. Now let us see how do we calculate that. Okay. So it is called as width or thickness. Both the word you can use, thickness or width. Okay. Thickness से म्हणलं तर चालतंय, width आहे म्हणलं तर चालतंय. तुम्हाला जे convenient वाटते ते use करा. Here, width of stem at bottom. Now we need to find out this. Okay. So now consider per meter length of the wall. Okay. Consider 1 meter length of the wall. Okay. moment m is equal to moment, that is moment m is equal to, what is the formula? It is half into k into gamma into h, okay, into again it is h into the centroid is h by 3. This is the formula for moment. कुठून आला हे formula? So now you have already studied it in geotech. Now suppose this is the base, this is the wall height, and now the soil pressure. We are considering here the soil pressure. So I will draw it like this. Now the resultant force is P. So this is the resultant force which will act at a CG over here. Okay. So this P is nothing but your earth pressure. Here it is P. Okay, P. This is your earth pressure. Here it is soil. Soil pressure is there. We call it as earth pressure. Okay. What is the centroid where it is situated? This is situated at distance of h by 3, where h is the total height. Okay. Where h is this total height. This total height is h. Okay. And what is this base? This base is Ka into gamma into h. This is the base of the triangle. The derivation of this is also there in geotech. Okay. You can go with that. So, by using this, you will calculate the answer. So now what is the value of K? K is the coefficient of active earth pressure. It is 1 minus sin phi divided by 1 plus sin phi, which is equal to 1 minus sin of phi is 30 degree divided by 1 plus sin of 30 degree, which is equal to 0.33. So this is the value of K. So now calculate the moment due to this soil pressure. Okay, at the base, what is the moment? बेसलाच का मोमेंट काढायला लागलो आपण स्टेमच्या, कारण की आपल्याला तिथे हे विड्थ कॅल्क्युलेट करायची त्याची किती असायला पाहिजे थिकनेस. थिकनेस वी कॅन से ओके, थिकनेस डेप्थ so now we will calculate it. So m is equal to half into k into gamma is 18, gamma is 18 into h, 5 meter is the height, half into base into height. Now if you see this triangle, half is there, k into gamma into h is the base, so k into gamma into h is the base and multiplied by height. So half into base into height, this is the area of triangle. Okay, and this should be multiplied by h by 3, that is 5 by 3. So here it is also 5, multiplied it by centroid, it is acting at the centroid, so 5 by 3. After solving this, we will get the answer. It is 125 kilonewton meter. So we will calculate the ultimate moment then. हे सगळं कशासाठी चालू आहे? आपल्याला स्टेमला विड्थ किती आहे, स्टेमची काय म्हणतात, स्टेमची थिकनेस आपल्याला पाहिजे, म्हणून हे सगळं चाललेलं आहे. to calculate the thickness of stem. हा ट्रायंगल का घेतला? हा स्टेम आहे, ही h म्हणजे स्टेमची हाईट आहे, हे खालचा बेस म्हणजे हे h म्हणजे स्टेमची हाईट आहे, हा बेस म्हणजे स्टेमचा बेस आहे. ओके, ऍट टॉपला आपली 200 विड्थ आहे, पण आपण अज्यूम केले की असा आहे ट्रायंगल म्हणून. 2.2 मीटर विड्थ इज very small, 0.2 मीटर थिकनेस इज very small, 0.2 मीटर. ओके, 200 mm. ही आपल्याला बेसला काय पाहिजे, त्याची थिकनेस पाहिजे, म्हणजे डेप्थ बेसची थिकनेस. त्यासाठी आपण बेसला मूवमेंट घेतोय, कुणाची? अर्थ प्रेशरची. ओके, so now that was the answer. Moment time is equal to, it is 1.5 into 125, it is 187.5 kilonewton meter. This is the moment. Okay, so this is our ultimate moment. So I will write here ultimate moment. Ultimate moment is equal to 1.5 into 125, which is equal to 187.5 kilonewton meter. So ही अल्टिमेट मोमेंट आली तुमची कुठं? स्टेमच्या बॉटमला. ओके, जर तुम्ही डायग्राम बघितली तर हा आता इथं हा असा स्टेम असणार आहे, तर ह्याचा हा जो बॉटम पार्ट आहे इथं, तर आपण तोपर्यंत थिकनेसला डी म्हणू. ओके, हे डायमेन्शन डी म्हणू. तर इथं जो आहे, तर हे इथं या पार्टला जी मुवमेंट आलेली आहे एम, ती किती आलेली आहे? 187.5. ओके, वरची आपण फिक्स केली आहे विड्थ, म्हणजे विड्थ म्हणा, डेप्थ म्हणा, थिकनेस म्हणा, थिकनेस ती 0.2 मीटर आहे. खालची थिकनेस आपल्याला काढायची. ओके, सो आय विल कॉल दिस एज थिकनेस, सो देयर विल नॉट बी कन्फ्युजन फॉर यू. थिकनेस T. So now we will equate the bending moment to moment of resistance. Equate Bm to moment of resistance. That is 187.5 into 10 raised to 6 is equal to 0.138 FCK. B, D square instead of D, I will write here T. T square. Thickness required. Okay. Therefore, it is 187.5. Notation doesn't matter, value matters. So now we have used this formula many of times, you know that. Into B per meter, so it is 1000 into T square required. So calculate the value of T, thickness required, and let me know the answer. T required. Calculate this answer. What is the thickness required? So it is 260.64 mm. Okay, so which we will round up to 261 mm. So assuming effective cover, so the thickness is 261. So assuming effective cover is equal to 40 mm. So I am directly considering the effective cover. I am not considering here clear cover. I am directly assuming effective cover. So therefore, overall thickness T. Okay. So overall thickness T. Overall thickness T is equal to thickness T is equal to, it is how much? 261 plus 40. So it is 301 mm. Okay, 301 mm. So increase the thickness, okay, by 30 to 35% for safe design. Okay, so here increase the stiffness by 30 to 35% for safe design. Okay, so we will increase that thickness. So thickness, I am talking about overall thickness. Capital T I am writing over here, thickness. So overall depth la capital D into the thickness. So increase it by 30%. We will increase it. So 301 into 1.3, increase of 30%. So it is 391.3, which we will round it up to 400 mm. So top ला thickness किती आहे 200 आणि bottom ला thickness किती आली 400. Okay. So I will write here thickness of stem at bottom is 400 mm. So in short, if I draw the diagram, it will be like this. This is your stem. Okay. This is 200 mm, and add this is 400 mm. Okay, and this is your stem. So we have fixed the dimension of the stem. Okay. So remaining part we will take in the next lecture, as I am having a meeting now. Okay, within 5 minutes. So the remaining part we will cover in the next lecture. Next lecture this problem will get covered, and after that lecture we will take one problem of circular water tank, so that it will be over. Okay, so